Okay, so this section, and hopefully I've told you this in class, is actually from the back of your book in Addendum A. So there's a couple more words to add on here. First one we have today is nth root. Nth root. So we know about square root. We've talked about cube roots. Nth root is any root I want to give you. I think I mentioned that in the other videos, like fifth root, sixth root, seventh root, billionth root. I think I even made a comment about. So that's what this one is about. Now, here's the idea. If a to the n equals b, with a and b are real numbers, this is important, and n is a positive integer, then a is the nth root of b. Now, there's a couple of stipulations that kind of go along with that. If n is odd, right, so that nth root, if n is odd, okay, there is one real nth root of b. That's pretty important. Denoted in the radical form, right, the nth root of b, there is one real one. By the way, the only nth root of 0 is 0. I should throw that out there. If n is even, right, so that n right there, that n, same n, by the way, is even, and b, right, is positive, then there are two real nth roots of b. The positive root is the principal root. So I don't think it's one of your vocab words, but it's something we will use and discuss, or principal nth root. And its symbol, nth root of b. The negative root is its opposite, or the negative, the opposite of nth root of b. Now, again, if n is even, so I know there's a lot to swallow there, and we'll do some examples. If n is even and b is negative, there are no real nth roots of b. Okay? That's when it's even. We'll do some examples. Okay, so looking at those different examples, different ways of thinking about this. Let me bring that back in real quick. So let's start with the example where n is odd. I'm just going to use cubed root because it's easy to wrap our head around. So if I have the cubed root of 8, right, then there's only one here. 2 times 2 is 4 times 2 is 8. So it's 2. Now, it doesn't make a comment about odd, whether it's positive or negative. That's because it doesn't matter. So if I have the cubed root of negative 8, that's still going to be negative 2 times negative 2 times negative 2. So, again, the cubed root is negative 2. So that's an instance where n is odd. But when n is even, and I'm going to stick to a simple example here. I'm going to use fourth root. I mean, you could use squared because that certainly applies here. But I'll use the fourth root just to kind of demonstrate that. So if I have the fourth root, so our n is even and b is positive. So let's say positive 16. 2 times 2 is 4 times 2 is 8 times 2 is 16, right? So the answer is going to be 2. But if b is negative, so if I try to take the fourth root of negative 16, there is no real nth root, no solution set. Right? It's not 0, it's no solution for this. Because I can't take a negative times itself 4 times in order to get a negative, because that negative 2 times negative 2 is positive, right? Times another negative 2 is negative, but that fourth one, that fourth negative 2 makes it positive 16 again. So we get the idea there. So that's the difference between the positive and the negative. And to me, this seems like one of those things that should be more or less plain sight to you, but except for maybe this side, the whole odd things. So, alrighty. So continuing that idea, the nth root of the nth power. So again, for any real number, a to the n. If a is odd, a is the answer if n is odd, right? The absolute value of a if n is even. The idea here, and again, I'll do an example in just a second, is to force you to use that principal square root like we mentioned 2 slides ago. That's what the absolute value does for us. So you can't throw in a magic negative and have it come out magically true. And that example's on the next slide, by the way. Okay, so I'm going to use variables in this discussion to make it a little more generic than just numbers. But here's the idea, okay? And the reason the absolute value, and I'll show you this here with the whole odd even thing, the reason the absolute value comes into play is that when n is even is that it forces us to, just in case the number were negative, it forces it to not produce an extraneous solution, which we talked about before, right? The idea that -2 times -2 is 4, but if I'm trying to get the cubed root, right, with -2 times -2 times -2 for a positive 8, right? Trying to get that principal square root idea, if that makes sense. Let's do this. We're going to do a ton of examples, let's say that, and I'll put a simple one in here for us. So, the 4th root of x to the 12th. Think about it this way. Technically, x to the 12th, in this case, is x cubed times x cubed times x cubed times x cubed, right? If you think about your rules, we're going to add the exponents across here, right? We're going to add these exponents to get that x to the 12th. Now, there's 4 of them. So, technically, the 4th root of x to the 12th, so let me rewrite that another way that maybe makes more sense. The 4th root of x to the 12th is really x cubed, right, 4 times. And we can see here, since n is even, right, we need the absolute value of that x cubed. And again, that's just in case it were a negative, it's going to force that positive to come back out. Again, we're going to do lots of these, right? This is your example. And I'm going to sympathize with your pain right now. This is out of the Algebra 2 book. It's going to be a couple of years till you see this. But until you see it on a regular basis, it becomes part of all the things you're going to do. But we're doing it anyway this year. Alrighty. Likewise, if I want the cubed root of x to the 12th, that's really like x to the 4th times x to the 4th times x to the 4th, right? There we go. And in this case, so if you think about it this way, like we did before, that's x to the 4th, right, cubed. So that means the answer is certainly x to the 4th. In this case, I don't need, right, the absolute value because the 4th is going to take care of it. It's going to kill it. So what we're looking at here then is right here, again, the end part here, right, versus the end part here. Okay? Does that make sense? We'll do some more examples in class. And if you need them, ask all you want. We'll do as many as we need to.